Okay, so prior to using constructors, we saw that if we have to assign input values to data members of a class or data members of an object rather, then we would have to use member functions, right? For example, let's say I have a class, called demo. Let's say I have a class called demo and I do not know anything about constructors. And let's say this class demo has one data member called D. Now, what would I want? I would want to give this data member some value. Now for that, I would have to write a function like input. Let's say I would write a member function like input, and let's say it's receiving a parameter m. Now whatever this m is, that would be assigned to D. Right, and let's say there were other functionalities present in this class as well. But my objective is to only show how this input works. Now, let's say somewhere in my main method, I create an object of this class demo. So I write demo D. Right? Now, after creating an object, I want to give it an initial value. Now, in order to give it an initial value, what would I do? I would call this function. So I would call this function like this, d dot input, and let's say I give it a value of 6. Then what would happen? This object would be created D. Now this object D has how many data members? It has one data member. Okay, since the name of the data member is D, let me take another name for the name of the object. Let's call it OB. Okay, let's call the object OB. Since the name of the data member is D, I don't want to confuse you, that's why I've just changed the name. And let's say I'm passing a value of 16. Okay, but it's not like I can keep the name as D as well. See, here D is a data member and its scope is this class. Now this variable that I'm creating, which is an object of class demo, the scope of this variable is within the main method. So it's fine if I have same name in these two cases. It wouldn't be a problem, but just to avoid the confusion, I'm using a different name. I'm using the name OB. So if I create an object OB, then it would have one data member, which is D. Now, if I would call this function input, then this 16 would be passed to M, and this M will now give the value to D. Now, D would get a value of 16. Which D is this? Remember, every object that we create would have its own instance of the data member. So this D refers to the D data member of object OB. So the object OB has a data member D and it gets a value of 16. So every time I create a new object, what do I have to do? I have to call this function input. If I want to give my data members an initial value, then I have to call this function input every time I create a new object. Now this is fine for small programs where you're creating few objects, but the moment the number of objects that you start creating increases rapidly, let's say you're creating 100 or 200 objects, then it's very difficult to keep track of the fact that whether you have invoked such input functions for every object to give their data members an initial value. Now, what is the solution to this problem? The solution to this problem is constructors. How? Because constructors will enable automatic initialization of objects. That means if I define a constructor, the moment I create an object like I have done here, the data members of this object will get initial values. Now those initial values will be depending on the type of constructor that I'm using. There will be various types of constructors, we'll see them shortly. But depending on the values that I am providing and depending on the type of constructor I'm using, my objects will automatically get those initial values. Okay, so now since you have understood the motivation behind using constructors, let's see what a constructor actually looks like. In order to be able to understand constructors properly, we need to ask ourselves a few questions. These are the few questions that we need to ask ourselves, find the answers to them, and then proceed further. Okay, so the first question is, what is exactly a constructor? See, you can note this down. A constructor is a constructor. Okay, in short, I can write a constructor as CTOR. Okay, Constructor in short is written as CTOR. Now, what is a constructor? A constructor is a special member function which is invoked automatically when an object of the associated class is created. I'll repeat myself. A constructor is a special member function which is invoked automatically when an object of the same class as the constructor is created or is instantiated. Objects are instantiated. So I can say that, I'll repeat myself once more. A constructor is a special member function which is invoked automatically when an object of the same class as the constructor is instantiated. So this was the answer to the first question. Now, the second question is followed straight from the answer to the first question. I had mentioned that a constructor is a special member function. Now the question is, why is it special, right? Why is a constructor called a special member function? See, a constructor is a special member function because it has the same name as the class of which it is a part. Remember, a constructor will always have the same name as the class of which it is a part. That is why a constructor is called a special member function. You take any member function, you will never have the name of the function to be the same as the name of the class. But a constructor is a special member function. Why special? Because it has the same name as the class. Now, the third question is, when is it invoked? When would a constructor be invoked? A constructor would be invoked automatically when an object of the same class as the constructor is created. Remember this, once you instantiate an object of a class, the class's constructor would automatically be invoked. And number 4, why is a constructor so named? Like, why is a constructor called a constructor? A constructor is called a constructor because it enables us to construct objects of a class by assigning proper values to the data members of the objects. A constructor is so named. That means a constructor is called a constructor because it automatically constructs objects by assigning proper values to data members of the objects. Okay, so these were the few questions whose answers were necessary. Now, let's see an example on constructors. Now see, we have taken this example where I have defined a class called integer. This integer class has two members, m and n. Both are integer variables and they are defined in the private section of my class. And in the public section, I have defined a function, as you can see. How can I say that this is a function? Because after the name of the function, I can see opening close parentheses. This opening parentheses and closing parentheses together makes me identify that this name represents a function. And this function takes no arguments. That's why inside the parentheses, I have written void. See, writing this void and leaving the parentheses empty means the same thing. Okay, just keep that in mind. And this is the constructor declared. So how can I say that this is a constructor? See, there are a few things that will help you to identify whether a member function is a constructor or not. The first thing is the name. Look at the name of the class. The name of the class is integer. And look at the name of the function. The name of the function is also integer. That means this is a special member function which has the same name as the class. One more thing, notice that this member function has no return type, not even void. So remember this point, that all constructors will have no return type, not even void. Okay, constructors will have no return type. Because, okay, now a question may arise, that is, why does a constructor not have a return type? See, a constructor has no return type because it is firstly automatically invoked and it does not have to return any value to anyone. Since it is automatically invoked, so nobody is calling the constructor, right? It automatically gets invoked once an object is created. As a result, since no one is calling it, it has nothing to return to anyone. This is the reason why constructors have no return type. Since nobody calls a constructor, it has nothing to return to anyone. That's why we have a constructor defined or declared in this case. See, a constructor is declared here in this way. Now, outside the function, I am defining my constructor. So what is the format? The format is return type. Since the constructor has no return type, I have nothing to write. then comes the class name, which I've written, integer, then is the scope resolution operator, and then is the name of the function, which in this case is the constructor, which happens to be the same as the class name. And here again I've written void. So leaving it empty or writing void means the same thing. And what is this constructor doing? It is simply assigning the data members m and n to the value 0. Okay, so since assignment operator is right associative, I can do this, right? So what will happen is, since assignment operator is assigning values from right to left, so 0 will first be assigned to n, and then the value in n, which happens to be 0, will be assigned to m. So I can do this in one line. Now, this is fine. I guess this is understood. You can copy this down. Huh? You can pause the video for a moment and copy it down. So I hope you have copied it. Now see, the question is, what will a statement such as this have an impact on this program? Or how will the program execution flow change depending on a statement like this? So let's examine it. Now, what am I doing here? I am creating a variable called I1, and the type of the variable is integer. Now, I can see that integer represents a class. Now, what is the main use of class? The main use of class is to create user-defined data types. Like in C, we have structures to create user-defined data types or abstract data types. In C++, we have classes to create abstract data types or user-defined data types. Here, I have defined a class. That means I've created a data type of my own. And what is the name of that data type? The name of that data type is integer. Now I'm creating a variable of this type. And what are variables of classes called? Variables of classes are called objects. That means I've created an object called I1, and which class does this object belong to? This object belongs to class integer. Now, the moment I create an object, like you saw in the previous few minutes, I mentioned that the moment I create an object, the constructor is automatically invoked. So, because of this statement, the constructor, that means these few lines, okay, I'm sorry about that, I'll just change the pen. Just give me a moment. Okay, so because of this line, because of creating an object, what will happen? This function will get invoked. The constructor will get invoked. Remember, whenever you create an object, what happens is the object, okay, this is not working either. Okay, the pens are giving up on me. See, the moment I create an object, what happens is memory is allocated. For when I create a class or when I define a class, no memory is allocated. Keep that in mind. No memory is allocated when a class is defined, but when I instantiate an object, memory is allocated. How much amount of memory? The amount of memory that is allocated for an object depends on the number of data members it has. How many data members does this object have? This object has two data members. One is m and the other is n. So, sufficient amount of memory to accommodate values of m and n variables will be allocated. So, I'll have memory equivalent to the size of two integers. So, one is for m and the other is for m. Now, because this statement will automatically invoke the constructor, what will happen? M and n both will get the values of 0. Now, which m and which n am I talking about? I am talking about the copies of m and n of the object I1. I am talking about, see, every time I create an object, every object will have its own copy of the data members. That means if I have another statement, let's say I write integer I1 comma I2, then what will happen? I1 will get its own copy of the data members m and n. I2 will also get its own copy of the data members m and n. It will also get its own copy of the data members m and n. Now, here what will happen is, let's say I2 does not exist. This was just to give you an idea of how objects are instantiated. But coming back to our point on constructors, so the control flows here. Now, m gets a value of 0 and n also gets a value of 0. And this m and n are the copies of I1. So, m gets a value of 0, n gets a value of 0, and the control again returns back. Now, what happens here is the constructor automatically initializes these two data members. So, compare this with the input function which I showed you at the outset of this video. What happened there? Every time I was creating an object, I had to invoke or I had to call the input function separately. But here, the moment I am creating an object, the constructor is getting invoked automatically. The constructor is called automatically. So, I do not have to keep that headache of, okay, the moment I'm creating an object, okay, I also have to call the function. So this headache I do not have to keep track of. Okay, so things become a lot simpler the moment I start using object-oriented programming principles, and constructor is one such object-oriented programming principle which is used indiscriminately in C++, because it helps us to get one step closer to the fact that C++ enables us to create data types of our own. See, with the help of a class, you're creating your own data type. Now, what are constructors enabling you to do is they're helping you to declare and initialize data members, or rather data members of objects automatically as they're created. Like, I can have a statement like this, right? I can have int x equal to 3. So the moment I am declaring a variable called x, I am also initializing it a value. I want to do the same thing for my user-defined types. So this is what is happening. The moment I am creating an object, it is also getting initialized. And by initialization of an object, I mean giving initial values to its data members. So here, its data members get the initial values that are required. Now, if you remember, then right at the beginning, I had mentioned that there are different types of constructors. So what is this type of constructor called? This type of constructor is known as a default constructor. This type of constructor is known as a default constructor, or it is also called a no argument constructor. It is also called a no argument constructor, and it is also called as non-parameterized constructor. These are the three names. Okay, you can use any one. So you may be asked questions by using these three names interchangeably. Okay, so this constructor, since it's not taking any argument, it is called a default constructor, a no argument constructor, or a non-parameterized constructor. Now you may ask a question that since every time an object is created, a constructor has to be invoked automatically, what happens to programs where we do not write constructors? Where does the constructor come from? See, remember, the default constructor is one such constructor which is automatically provided by the compiler if we do not define one by ourselves. See, if I do not define a default constructor myself, that means if I did not have a statement like this, then the compiler would provide me a default constructor. Okay, so this is one thing that you need to keep in mind, that out of all the constructors that we'll be studying, default constructors are one of those constructors which are automatically provided by the compiler if we do not come up with a default constructor of our own. Okay, so I hope this part is clear. What I'll do is, now I'll move on to the characteristics of constructors in the next video. So if you have any doubts, please feel free to comment in the section below. Thank you so very much for staying tuned to my channel.